Lysozyme is an enzyme that catalyzes the breakdown of bacterial cell walls by hydrolyzing the beta-1,4 linkages between N-acetyl muramic acid and N-acetyl D-glucosamine sugars within the peptidoglycan, which makes up the cell walls of bacteria. So over here, we can see that there are two mechanisms that can occur, the SN1 and SN2 mechanism. Within most biochemistry classes, we are interested more in the SN2 mechanism, so this is what we are going to go over. Now we can see that we have our N-acetyl muramic acid over here, and we have our N-acetyl D-glucosamine sugar over here. Now what happens is that aspartate 52 within the active site of lysozyme is going to act as a nucleophile because we have this oxygen with a negative charge. So it's going to act as a nucleophile, and it's going to attack this carbon over here on the N-acetyl muramic acid. So we know that carbon can only have 4 bonds. That means it's going to lose a bond once it reforms that bond with aspartate. So what's going to happen is that it's going to break this bond between this oxygen over here. So oxygen is going to gain a lone pair because it's losing that bond that it had with the carbon. Now this oxygen, since it gained a lone pair, it's going to act as a nucleophile, and it's going to abstract the hydrogen off of glutamate 35. So when it abstracts that hydrogen, this oxygen, which was negatively charged, will become OH. And we see that over here. And this is going to be our first product. So what happened is that aspartate acted as a nucleophile, nucleophilically attacks the carbon. Carbon can only have 4 bonds, so it's going to lose one of its bonds, and it's going to be the one with oxygen. Oxygen gains a lone pair, and negatively charged is going to attack and abstract that hydrogen off of glutamate, and it's going to be our first product. Now this is going to leave glutamate without a hydrogen, so glutamate will now have a negative charge, and we see that aspartate has now formed that bond with carbon. Now, going on to the next step over here, remember that whenever we have an enzyme, we have to end up just how we started. So we can't just end with the aspartate bound to this compound over here. We have to break this bond now somehow. Now we're going to break this bond by adding in water. So over here, we're going to move over here. So we're adding in water, and now what's going to happen is that, remember that this glutamate, it's negatively charged because it lost its hydrogen. So that means this oxygen has a negative charge, it has that extra lone pair, and it's going to abstract that hydrogen. It's going to act as a nucleophile and abstract that hydrogen off of water. Now, when this hydrogen is abstracted off of water, now this oxygen over here, it's going to gain a lone pair, gain a negative charge. Now it's going to act as a nucleophile and attack this carbon and form a bond with that carbon. Now, right now I'm over here, I'm going through the SN1, but I'm going to hop over here so we keep on track with the SN2. So same thing still happening. Now what happens is that when this bond forms with the oxygen, carbon can only have 4 bonds. So it's going to lose one of its bonds, and it's going to lose the bond that it formed with aspartate. So it's going to lose the bond with aspartate. Now aspartate is going to gain a lone pair, gain a negative charge, and now we see that this carbon, it has actually formed an OH bond over here, which this OH, it originally came from the water. So to make this thing simpler, I'm going to cross this out because we're not concerned with this part. So to go over quickly one more time, what happened is that aspartate within the active site of lysozyme acts as a nucleophile, attacks the carbon. Carbon loses the bond with oxygen because carbon can only have 4 bonds. Oxygen now has a lone pair, abstracts the hydrogen off of glutamate. Glutamate now has a negative charge. Once we add in the water, that negatively charged glutamate is going to abstract that hydrogen off of water, which is going to make this oxygen negatively charged with a lone pair, which is now going to attack our carbon and form a bond with that carbon, which is going to cause carbon to lose one of its bonds because carbon can only have 4 bonds. So now aspartate has gained its lone pair, and it has that negative charge just how it was in the beginning. And now we have our second product. So through the lysozyme mechanism, we get two products, and just how our enzyme active site looked in the beginning, that's how it's going to look in the end, where our glutamate is protonated and our aspartate is deprotonated. And that is the lysozyme mechanism. It's a hydrolysis reaction of the beta-1,4 linkages between N-acetylmuramic acid and N-acetyl D-glucosamine sugars within the peptidoglycan of bacterial cell walls.